What was the first general-purpose computer? Nowadays, when somebody says computer,
Computers,
you immediately think of a PC like this one or a laptop. But if we were to trace their family tree back to the very first ancestor, who would be sitting at the top? This question recently popped up in my mind, and I thought that a simple Google search would quickly yield answers. But instead, I was sent down the rabbit hole. I went through numerous articles, forums and papers, and eventually I realized that the most common candidate that I found might be wrong. Most sources identify the American computer ENIAC, completed in 1945 as the world's first general-purpose computer. Case closed. Except I don't think this is that simple, and by the end of the video you will understand why. First of all, the key to answering this question actually lies one layer deeper, namely, we have to define what a computer really is. And this by itself is not an easy task. I first landed in the most obvious place, the dictionary. Cambridge Dictionary defines a computer as an electronic machine that is used for storing, organizing and finding words, numbers and pictures, for doing calculations, and for controlling other machines. That sounds reasonable. Modern computers certainly do all of these things, but not all of these capabilities are essential. On early computers, you couldn't scroll through Instagram or render a 3D donut, yet we still call them computers. So if the stuff it does doesn't define it, what does? I will get to that in a moment, but for now the bigger issue in the dictionary definition is the word electronic. Does a computer really need to be electronic? Well, no. Computing in itself is a very abstract concept, and limiting the medium of information discards an entire group of computing devices that don't rely on electricity. For example, light-based computers, which I covered in my previous video, or mechanical computers. This last group initially became my lead. Analog computing devices have been present since ancient times, so I searched for the oldest known mechanical computing device that I could find, and I found this, the Antikythera mechanism. It is the oldest known analog computer, which is believed to have been created around the 2nd century BC. It consisted of several cogwheels and gears, and it could be used for astronomical calculations, such as predicting solar eclipses decades in advance. Some historians consider this machine to be the first computer, and I could probably end the video here and call it a day. But I think that would be inaccurate. The device was a computing machine, no doubt, but can we really classify it as a general-purpose computer? I don't think we can. It was not programmable, it could not store arbitrary data, and it was designed to do one very specific task. From this, we can draw that a computer is something more than just a machine which performs some arbitrary calculation. What we are looking for is a general-purpose, universal machine capable of performing all sorts of calculations. I'm going to cut to the chase and tell you that the precise definition that we are looking for is Turing completeness. Let me explain. In 1936, a British mathematician named Alan Turing tried to define the theoretical limits of what a machine can do. He came up with a device, now called a Turing machine, which in theory was able to compute anything that is computable. It was not a physical machine, but rather a mathematical model. The Turing machine consists of a tape divided into cells that store symbols, a read-write head that moves left and right, and a finite set of rules that determine how symbols are manipulated. The crucial part is this. Given enough time and memory, a Turing machine can compute anything that is computable. That includes arithmetic simulations, cryptography, games, and any algorithm you can describe. It can, in theory, even process this very video that you are watching right now. A system is called Turing complete if it can simulate such a machine. This concept gives us a precise definition of a general-purpose computer. It is not defined by what it does, but what it could do. And unlike the dictionary definition, Turing completeness says nothing about electronics, gears, or silicon. It only cares about computational capability. So, the natural next step was to look for the first Turing-complete machine. And this is where things get really interesting, as design for such machines might predate the actual definition. In 1837, the English mathematician Charles Babbage designed the analytical engine. arguably the first schematic for a general-purpose computer. The design featured many crucial components, still present in modern CPUs, such as an arithmetic logic unit used to perform calculations, integrated memory, and control flow logic that supported loops and conditional branches. That last term, conditional branching, is especially important in the context of universal machines, as it allows the machine to perform different types of calculations based on some previously computed value. And most importantly, the analytical engine was Turing complete, even though that term would only be defined a century later. But the problem is that it was never built. So, does a machine count if it only existed as a blueprint? Babbage couldn't complete construction due to inadequate funding, and the world would have to wait another 100 years before the first reliable digital general-purpose computer would be constructed. We are now very close to finding the answer, but this is where things start to diverge. Also, if you've been enjoying this video so far, make sure to subscribe, as 98% of people watching my videos are still not subscribed, and it would immensely help the channel if we could change that proportion a bit. During World War II, advancements in computing accelerated rapidly, driven by urgent military demands, especially cryptography. In 1943, researchers from the University of Pennsylvania began working in secret on a fast, fully electronic computer after receiving a contract from the US Army. 2 years later, the Electronic Numerical Integrator and Comparator, ENIAC for short, was completed, and it is often considered the first programmable, electronic, Turing-complete, general-purpose digital computer. It was a large, room-sized machine composed of modules that performed different functions, like arithmetic operations or data storage. When it comes to programming, ENIAC supported complex operations such as branches, loops and subroutines. But originally, the entire computer was essentially one giant plugboard, and each program had to be hardwired. This task could take a team of skilled programmers weeks of intense work. When I was researching for this video, ENIAC was the most commonly named as the candidate for the title of the first computer. But you might remember that in the intro I said that this might not be entirely correct. You see, the world's first general-purpose computer might have actually been built on the other side of the conflict. A German inventor and a computer pioneer named Konrad Zuse was designing and building computing machines since as early as 1935. His first machine, the Z1, was built in 1938 in his parents' home. It was a programmable, mechanical calculator that was driven by an electrical motor. Its main issue was its very limited reliability, as it could only work for a few minutes before running into errors. Nonetheless, Zuse kept improving his designs, and his third machine, the Z3, was completed in 1941, 4 years before the American ENIAC. The Z3 was the world's first programmable, fully automatic, electromechanical digital computer. Unlike ENIAC, it wasn't electronic and it didn't use vacuum tubes. Instead, it was built from around 2,600 electromechanical relays, essentially electronically controlled switches. The Z3 used binary floating point arithmetic, which is strikingly close to how modern computers represent real numbers, and programs were read from a punched tape. So, if the Z3 was built before ENIAC, why are some sources claiming that the latter was the first computer? Well, there are a few reasons for why the Z3 is considered a controversial pick for that title, among them the historical context of how the machine came to fruition, but most importantly, it has to do with the computing potential of the Z3. The German machine didn't support conditional branching, which, as we already mentioned, is crucial in the context of Turing completeness. But decades later, in 1998, Professor Raúl Rojas has shown that it is possible to implement a universal Turing machine on the Z3. He proposed that in order to implement conditional branching, the program tape would have to be long enough to execute all possible paths through both sides of every branch. By exploiting mathematical properties, all possible answers would be computed, but the unneeded ones would cancel out. Rojas concluded that from an abstract theoretical perspective, the computing model of the Z3 is equivalent to the computing model of modern computers. That would make the Z3, not ENIAC, the world's first general-purpose computer. But then again, if you really want to get strict with the concept of Turing completeness, a Turing machine has an infinite tape by definition, therefore infinite memory. In that regard, there was no first computer, and There never will be.